This is Mayo Clinic Talks, a curated weekly podcast for physicians and healthcare providers. I'm your host, Daryl Chutka, a general internist at Mayo Clinic in Rochester, Minnesota. The cells in our nervous system are extremely specialized, especially those in the brain. When these cells are damaged by either illness or injury, in many cases, the function those cells controlled, such as speaking or walking or even remembering, is often lost forever. Unfortunately, nervous tissue does not have a great potential to regain function once its function is lost. Exciting research is being done in the field of neuro-regenerative medicine, which will give hope for improvement to those with chronic neurodegenerative disease or nerve damage from injury. With us to discuss the field of neuro-regenerative medicine is Dr. Nathan Staff, a neurologist at the Mayo Clinic. Nathan, welcome.
Thank you for having me today.
In the field of neurology, what are some of the unmet patient needs, and how will regenerative medicine address some of those needs?
Yeah, no, that's a great question. I think you touched on it a lot in your introduction, and that in neurology, especially when thinking about the brain and spinal cord, the neurons that live there, once they've been damaged and die off, they don't replace themselves. There's no real true regenerative capacity of the brain or spinal cord once it's been injured, and that can be either because of a neurodegenerative disease such as Alzheimer's, ALS, or Parkinson's disease, trauma, or stroke. All of those can lead to really irreversible damage. And so I think in those areas, there is a great unmet need to try to be able to improve the brain and spinal cord function after it's been damaged. Regenerative medicine offers the hope of ultimately trying to replace neurons or replace other brain and spinal cord tissues. I think right now, much of what's being done in neuroregeneration focuses more on neuroprotection. So using cell-based therapies to be able to get into the spinal cord or brain to be able to slow down damage or affect neuroinflammation in ways that hadn't been able to be done before. But I think there's really, there are great unmet needs in neurology, and I think regenerative medicine has the capacity to help in that area.
Yeah, it's an amazing concept of regeneration, in that you can't just replace a nerve with a nerve. It's got so specialized function, maybe a motor nerve, or maybe a sensory nerve, maybe an autonomic nerve. So in addition to the body accepting it, I mean, it's got to have a very specialized function, which is just mind-blowing to me. I'm not quite sure how this works, but I guess I'm not a neurologist.
Yeah, it is a challenge. It's not only the specialization from kind of the biology of the nerve, it's the structure of a nerve is rather mind-boggling as well. So for example, the nerve that connects to the muscle to allow your toe to wiggle, the cell body for that nerve lives in your spinal cord, but then an axon grows out of that neuron and goes all the way down to the muscle. So you're looking at a single cell that by itself can be 3-4 feet long, and being able to regenerate that once it's been damaged or dies off is really a very complicated biological problem.